This is an explanation of finding the derivative of an inverse function. So let's go over first let's take a look at a proof first actually, which is over here. We start with g of x is equal to f inverse of x. So really we're looking for g prime then, which will be f inverse prime. And so the first thing we can do is take f of both sides. And in doing so, the left side is f of g of x, the right side is f of f inverse, which cancels down to just x because these are inverse functions. Now we take a derivative of both sides, the left side becoming f prime g of x times g prime of x by the chain rule is equal to 1. And recall that we're trying to solve for g prime. So divide both sides by f prime of g of x to get to here. And we're almost there, we just fix up the notation a little bit. So g prime of x is really f inverse prime. And then instead of writing g of x, I'll write f inverse of x. So this is a formula then for the derivative of the inverse function. Now we can look at this graphically in a couple different ways. Let's take a look over here. Now what we have here is a point sliding along a function. Take a look at the tangent and the slope of the tangent moving. Here's the inverse function, which is symmetric about the line y equals x. And then what we see is the inverse tangent as well. The tangent of the inverse, I suppose would be better to say. And the conclusion of coming over to here now, we can look at f of x equals x squared. This is going to have an inverse because it passes the horizontal line test. So if we take a look at specific values, so at x equals 2, we find the derivative there, it's equal to 4, so the slope is 4. Now we find the inverse by switching x and y. And so our inverse is rad x. And we go to the point, not 2 comma 4, we go to the point 4 comma 2. So you have to realize that you are switching x and y. And so the slope is 1 over 2 rad x, where now x is equal to 4. And so we end up getting a slope of 1/4, which of course is the reciprocal of 4. So there's the same idea. Slopes are reciprocals. So this is more a notation for what I was just talking about. Okay, another sample type of problem we could look at would be of this type. So we're given that f of 3 is equal to 5, f prime of 3 is equal to 6, and we want to find the derivative of the inverse of 5. And notice that the y value here is 5, whereas the input value is 5 for the inverse. So we have to switch those. So what you do is you've got your formula, and the derivative of the inverse of 5 is just 1 over the derivative of the regular function at 3. So 1 over 6. So that's all there is to that. One other point to make is when you're trying to see if you have an inverse function, there's the notion of monotonicity. And so if something's strictly monotonically increasing, it's always going up. And so it will pass the horizontal line test. Now you can tell if something is strictly monotonically increasing, of course, because the derivative is always greater than 0. So if the derivative is always greater than 0 or always less than 0, strictly monotonically decreasing, you will have an inverse because it will pass the horizontal line test. Now, sometimes you have to be a little careful because if you have something like y equals x cubed, it comes up and then it flattens momentarily. Now that has an inverse. However, at this one point right here, the derivative is equal to 0.